Today's lesson's on special right triangles. So those are 45, 45, 90 triangles and 30, 60, 90 triangles. So we're going to learn how to find the missing sides, okay, of a special right triangle. All right, so we're going to start with 45, 45, 90 triangles. Okay, 45, 45, 90 triangles are isosceles triangles. Okay, as you learned in geometry, when you have two congruent angles here, base angles, then their sides have to be congruent. So since both of these angles are 45, okay, their opposite sides both have to be congruent as well. All right, so we're going to start knowing that whatever side those are, n for right now, then the hypotenuse will always be n rad 2. Okay, so um, if n was 5, right, and then the hypotenuse would have to be 5 rad 2. Okay, so it's saves us the time from having to do the Pythagorean theorem, and we can only do it if we know one side. With Pythagorean theorem, you need to know two sides. Okay, with special right triangles, okay, you only need to know one side, and you should be able to figure out all the other sides. All right. So let's look at an example here. All right, so this is a 45, 45, 90 triangle. So how do I know that if only one is labeled? Okay, well, because triangles have to add to 180. So this is 90, this is 45, so this one also has to be 45. Okay, and so what do we know? We know that the two legs of the right triangle, the two sides, the non-hypotenuse sides, okay, have to be congruent. So if that's 3, then x has to be 3. Right? And then based off of our notes on the last slide, the hypotenuse is always the side times rad 2. So the y is 3 rad 2. Okay. So that's how you would do that. There's no work really involved in this. If they give you that side, we just know we're just multiplying it by rad 2 to get the hypotenuse. Okay, you just got to know the pattern. All right, so again, okay, this is a 45, 45, 90. Okay, so we call this an isosceles triangle. And yes, all 45, 45, 90 triangles are isosceles. An isosceles triangle, again, by definition, is when they have two congruent sides. Right, so which means that this is 8. And then for the hypotenuse, we just have to multiply the side times rad 2. So the hypotenuse is 8 rad 2. All right, very straightforward, very simple. It's just remembering the rule, okay, that we need to be good at. All right, so now what if they give us the hypotenuse? Okay, so again, this is 45, 45, 90 triangle, and now they give us the hypotenuse. Well, there's two ways to do this. Well, they gave us the hypotenuse, and this is 15 rad 2. So this number right here has to be the sides. So both of these are going to be 15. Okay, but it's not always that easy. Okay, when you have the hypotenuse is given, because the hypotenuse does not have to have a rad 2 in it. So what would I do? I would have to kind of combine my knowledge of the Pythagorean theorem, a squared plus b squared equals c squared here. So, but what do we know about x and y's? We know they have to be the same. So we would kind of start off with a squared plus b squared equals c squared, starting off with the Pythagorean theorem. And then we start plugging things in, right? We'll get x squared plus y squared equals 15 rad 2 squared. Okay. And so, but what do we know about x and y is we know that they have to be the same. So I could just substitute in, right, x for y. So it's x squared plus x squared equals, and then if you actually do square that, you get 250. Sorry, 225 times. That's wrong. There's that 225 times 2, 450. I'm good at math. There you go. Okay, now you get 2x squared equals 450. Divide both sides by 2. Get x squared equals 225. Square root both sides, x equals 15. I don't have to worry about the plus or minus 15 here because the negative doesn't make any sense. So obviously a lot easier if we understand the rule right there. All right, so here's a perfect example. So it's just 6. It's not 6 rad 2. So I mean, is this just half? Is it 3? No. Okay, because then it would be 3 rad 2 over here. So how do I set this up? So I'll set it the same way. Okay, we'll call both of these x because we know that x has to equal y. Okay, and then we could set it up as x squared plus x squared equals 6 squared. So you get 2x squared equals 36. We divide both sides by 2, get x squared equals 18. Then we square root 18. And x equals 3 rad 2. Which means both x and y are 3 rad 2. That's a 3. Okay. So is there a shortcut for this? And yes, okay. It's this number in front, okay, will always be half of that number than rad 2. So if this was 10, it would be 5 rad 2. All right, if it was 20, it'd be 10 rad 2. All right, if it's an odd number, then you're going to end up with a fraction, but it'd still be rad 2. All right, so this next slide kind of asks that question, is can we make a rule, okay, if they only give us the hypotenuse? So let's say the hypotenuse is n, right? So let's just make a rule right here, okay, for this slide. All right. All right, so to do that, we'll set it up. Okay, we'll call both of these x. And so we'll go x squared plus x squared equals n squared. If we solve this, we get 2x squared equals n squared divided by 2, x squared equals n squared over 2. You square root both sides. When you square root a fraction, you square at the top, you square at the bottom. So you're going to get n on top, and you're going to get rad 2 on bottom. All right, it's one way to leave your answer, but in math, we don't like to have radicals on the bottom, so we have to rationalize the denominator. So when you multiply the top and bottom by rad 2, you end up with that the sides will be n rad 2 over 2. Right, which fits back to that last problem where n was 6, right? 6 divided by 2 was 3, so it was 3 rad 2. And so we're going to have this general rule right here, okay, that if they give you the hypotenuse, then the sides are going to be the hypotenuse times rad 2 divided by 2. So that may save us some time if we want to remember that. All right, so now the other special right triangle is a 30, 60, 90 triangle. Okay, so now this is not an isosceles triangle. All right, so we have all 3 sides are different. Okay, we're going to have a short side of the triangle, which is opposite the smallest angle. All right, so the side opposite 30 is going to be the smallest side. The side opposite 90 is going to be the biggest side. And then the side opposite 60 is the middle. Okay, the smallest and biggest have a really easy connection to remember. Okay, the hypotenuse is always going to be twice as long as the short side. So whatever the side opposite 30 is, the hypotenuse will be twice as long. All right. The side that's kind of its standalone is the side opposite 60. That's the short side times rad 3. Okay, so whatever that short side is times rad 3. So I could give you any one of those and you should be able to find the other two because they're all connected through n. They're all connected. So if they give you this side's the hardest side to work with, okay, but we can still figure out what n is based off of that number. We just have to divide it by rad 3. All right, so let's look. All right, so here we're starting with, okay, an easy one because they give us the short side. The side opposite 30 is the short side. Okay, so we know that the hypotenuse will have to be double that. So y is just 16. Okay, and then the side opposite 60 is the short side times rad 3. That's 8 rad 3. And that's it. That's what we're looking for. We're looking for those two missing sides. Come right from the rule, 30, 60, 90 rule. All right, so you're trying on this one. Okay, so again, they give us the short side, the one opposite 30, so the hypotenuse is twice as long. And then the side opposite 60 is the short side times rad 3, so 6 rad 3. All right, and this next example here, okay, they're giving us the hypotenuse. All right, it's the side opposite of 90. So this is still going to be pretty easy because now I just know the short side is half of that. So the short side is 20. And now once I know the short side, okay, then the medium side, the side opposite 60, is just the short side times rad 3. All right, so again, when they gave us the hypotenuse, we could find the short side because we know the short side is half the hypotenuse. And then once we get the short side, we could find, okay, the middle side, the side opposite 60. Okay, and so here we go again. They gave us the hypotenuse, so we know that this will be 5, half of that. And then this side will have to be 5 rad 3. Okay, now what if they give us the side opposite 60? All right, okay, could be a little bit difficult. This example here is not, okay, because it's 4 rad 3. So they gave us that 3. So this 4 right here is going to be my n. That's my short side. So the side opposite 30 is going to be 4. Okay, and then my hypotenuse will be double. Okay. That's that one. Again, they gave us a nice side there. So pretty simple. Okay, same thing here. They give us this side 60. So the short side's got to be 2. And then the hypotenuse is 4. If they don't give you the rad 3, again, you know that this whole side is n rad 3. So if you want to just set it equal, like you could say n rad 3 equals 2 rad 3. Divide both sides by rad 3, right? And that's how I know n equals 2. And n, oh, I'm referring to n here. N is the short side. Okay. So that's the math behind it. All right, so again, let's just label these, okay? So it's with 45, 45, if we know, okay, these are the same, call those S sides, okay, then this has to be S rad 2. All right, and then if you have a 30, 60, 90, the short side, we'll call that S. And we know that the hypotenuse is double that. And the side opposite 60 is S rad 3. So you got to know these rules. Okay, doesn't matter if you use S, you use N, X, Y, doesn't matter. You need to know how these sides are connected to each other. This right here is for your notes. This is going to come up later when we start studying the unit circle. So take a look at that. Just more connections on how they're related here.